Good evening, everyone. So in this video, we're going to be solving this question. If cos theta is equal to √3/2, find tan theta over sine squared theta. So to do this, we'll draw a right angle triangle. That right angle here. So we'll call it theta. If we call it theta, this side becomes our opposite from our previous video. So just in case you don't know that, you can go and check it out. Then this side is our hypotenuse and this is our adjacent. Okay, so from the question we see that cos theta is equal to √3/2, and we know that cos is adjacent over hypotenuse, right? So the adjacent is √3 and the hypotenuse is 2. Okay, so we'll bring this result here into our diagram. So adjacent is √3, so this is √3. Hypotenuse is 2, so hypotenuse is 2. You don't have to write hypotenuse, opposite, and adjacent. You can just write √3 and 2. I did that so that it will be clearer for you to understand. So what we need to find is, we need to find our opposite. So how do we find our opposite? We use Pythagoras theorem. So we'll call it x. So we use Pythagoras theorem. So let's work on that quickly. So if you've not watched my video on Pythagoras theorem, you can go and watch it. It's on YouTube. So using Pythagoras theorem to solve this, remember we said x squared will be equal to the square of the hypotenuse minus the square of the other given side. So we have x squared is equal to the square of the hypotenuse here is 4 minus the square of the square root of 3, that is 3, because square will cancel out this, right? Okay, so we have 3. So x squared is equal to 4 minus 3 will give us 1. If we take the square roots on both sides, we can see that x is equal to 1. So we've seen that our opposite is 1. Our opposite is 1. So since our opposite is 1, we need to find tan theta. Tan theta. So now we have 1, 2, and √3. You don't have to rewrite all these things. I'm just rewriting it for my lack of space. So we have to find tan theta. So tan theta, TOA, is opposite over adjacent. Sorry, it's supposed to be A, adjacent. Okay, so my opposite is 1 and my adjacent is √3. Okay, so tan theta is 1 over √3. We could leave this like this, or we could simplify it using sword. You can say √3 over 3 or 1 over √3. Okay, so I think let's leave it as 1 over √3. All right, so the next thing we need to find is sine theta. So sine theta is opposite over hypotenuse. The opposite is 1, hypotenuse is 2. All right, so from the question, it is sine squared theta. What that simply means is we should square our results, right? So sine squared theta simply means we square our results. So 1 over 2 squared, and that will give us 1 squared over 2 squared, and that is 1 over 4. Okay, So the question, tan theta over sine squared theta is equal to, tan theta is 1 over 3, 1 over root 3 rather, 1 over root 3, so I'm going to write this, divided by sine squared theta. Sine squared theta is 1 over 4, 1 over 4, so if we solve for this, 1 over root 3, divide return to multiplication, and that will be the reciprocal of this, so that will give us 4 over root 3. So this is in sort form. We could work on this and give us 4 root 3 all over 3. So there is a way they work on that to get 4 root 3 over 3. So I think I should explain that just for clarity purposes. Okay, so there's what we call rationalization of the denominator in sort. So since our denominator here is carrying a root, we'll multiply the numerator and the denominator by these roots. So if we do that, that will be 4 times root 3, okay, all over root 3 times root 3. So when that happens, we have 4 root 3 all over root 3 times root 3 is 3. So that is it. Thank you for watching.